This is a mini lesson on going from mixed numbers to improper fractions. So starting with a mixed number, you have the whole amount here and the fraction here. And we want to turn all of it into a fraction. And we know that it's an improper fraction, meaning it's greater than 1, because we have 3 wholes right here. So it's going to be a larger numerator. So the shortcut way is the way that you're going to do most of the time, which is fine, but you should also know why it works. So the shortcut is you say, so you multiply 5 times 3, which is 15, and then you add the 2, so that's 17, and all of it goes over 5. So shortcut, multiply, add, and then put it over the denominator. So this works every time. It's easy, it works, but why does it work, and what's the thought process behind it that you can use when you want to really manipulate numbers and have a good hook into it so that you can do the shortcut and still understand the problem. So here's the thought process with the longer extended version, which is fine to do, and it gets pretty fast. You can also do it in your head, but what you're saying to yourself, these are the steps. I want to turn that whole number into a fraction. So I'm going to turn my 3 into, it's going to be a 1 plus a 1 plus a 1 plus my 2/5. So now I've just expanded it out. Then I want to take each of these ones and turn it into a fraction. And how do I represent 1 as a fraction? It can be any number as long as the numerator and the denominator are the same. And what do I want to pick? I want to pick a number that has a denominator the same as what I already have, because that makes it easier. So all of these turn into 5/5, and another 5/5, and another one, and then I still have my leftover 2/5. Okay, so again, this can still be done in your head. Now what you're doing is you are going to add up all of the numerators. So what do you have? You have here is your 3 times 5. That's why it makes sense for you to multiply 3 times 5, because what are you doing? Here's 3 5s. There's your 15. Why do we add the 2 up here? Because we're adding that leftover 2 over here. So the numerator will be 17. Why do we have 5 on the bottom? Because we're talking about a 5th sized part. That doesn't change. So our improper fraction is 17/5. So whichever way you do it, and you can get really fast at mentally calculating this in the long version as well, or you can know the shortcut. But either way, knowing that one whole can be represented as a fraction like this over and over, and then putting them all back together, that's the goal. So here's 3 more. Pause it, try it, and then check your work. So write it down, 7 3/8. The long extended version is we want to take that 7 and we want to represent it as 1s. So again, you're going to cut that out pretty quickly, but at least you should know how to solve it once or twice in case you get stuck. So this will be a 1. So there's my 7 1s plus my leftover 3/8. Then I want to represent my 1s as fractions. What fraction will I choose? I will choose a fraction that has an 8 in the denominator. How do I represent 1? Using an 8 in the denominator, it's going to be 8/8. That's 1. So each of these will become 8/8. And then you have still your leftover 3/8. Okay, again, you don't have to do this every time, especially when you get a large number here. You are not going to be wanting to write all this out, but you have to know that it is possible to do and why it's there. So again, why does this shortcut work? What are we showing? We're showing how many times did we represent 8 here? We represented it 7 times. So 7 times 8 is 56, plus my leftover 3 is 59. So how's that shortcut working? 7 times 8 is 56, plus my leftover 3 is 59. That's where the numerator comes in. Why is the denominator the 8? Because that is the size of the part. It's an 8th sized part, so that stays the same. That is also just the rule of fraction addition. So the 8 will stay down here. So your mixed number represented as an improper fraction is going to be 59/8. Okay, so again, same process. Represent the 5 as its parts. And the leftover 7/9. Represent each of the 1 as a fraction. I want to use my 9 as my denominator because that's the one that's going to work the best. So each one will be 9/9, which is 1 whole. Okay, then you add them all together. So we have 1, 2, 3, 4, 5. I can either count by 9s, 9, 18, 27, or I can just say, how many do I have? I have 5 of them. What is 5 times 9? Here's your shortcut. 5 times 9 is 45. And what am I going to add? I'm going to add this last 7. So 45 plus 7 is 52. Then my denominator is my 9, so 52/9. Okay, 4 2/3. Write it down and try it, and then check your work. So I need to represent my 4s as 1s. Plus my leftover. Then each of my 1s get represented as fractions. Okay, why does the shortcut work? So what I'm saying is 3, 6, 9, 12. 4 times 3 is 12. There's my 4 times 3. Then I'm adding my leftover 2. So that's 14. And my denominator is 3. So this equals 14/3. Okay, one more. Write it down and try it. Pause it and come back. So representing my 3 as 3 1s. Plus my leftover 1/6. Representing all of these 1s as fractions using the denominator of 6. Okay, why does the shortcut work? So what we're saying right here is we have 6, 12, 18. We have 3 times 6. What do we have here? 3 times 6. Why do we add that extra 1? Because we have 3 times 6 and we're adding that leftover 1. So we have 19. And on the bottom, we have our 6. So 3 1/6 is the same as saying 19/6. So the shortcut, 3 times 6 is 18. Add the 1, which is 19, and then put it all on top of 6. So expanded form, shortcut, whichever way you want to do it is fine. But knowing the expanded form gives you a deeper sense of like how the fractions work. You're going to have a good foundation and an easier time as you go forward. Knowing the shortcut is the goal, like you will do that because you don't want to be doing this if you have a number like this. I do not want to be sitting here writing 1 + 1 + 1 + 1 + 1 20 times and then converting all of that to fractions. That's kind of a waste of time and energy and paper. So, but you should know that what this is telling you is that you're going to have 20 times 3/3. And for the numerator part of it, that's like saying 20 times 3. So 20 times 3 is 60. And then you're going to add that extra 2 up there. So you're going to have 62. And why is it all over 3? Because the size of the part, it's a 1/3 sized part. So that's like saying if I were to break this into whole amounts, like if I were to represent 1 whole, it's a 1/3 sized part. So we're representing it in terms of 3s. So these 20, every time I have a whole 20, it's like saying all of it is shaded, all of it, all of it, all of it, 20 times. And then my leftover 2/3 is like saying I'm still having a 1/3 sized part, but only 2 of them are shaded in. So this denominator tells us what we're breaking up our whole amount into, or the size of the part, which is a 1/3 sized part, and that always stays the same. All we're doing with this is saying how many of those shaded parts are there. So that's like saying I'm going to have 20 of these shaded parts. It's 20 times 3, plus my extra 2/3 here, which gives me 62. So I think that's it. Again, there are lots of videos, so if this is not helpful, all you have to do is search in the search bar, turning mixed numbers into improper fractions. It's really, really important. So find a video that works for you, find a method that you understand, and really understand how to break apart the numbers and go between both of them. So another video will show you how to go from an improper fraction back into a mixed number, and you need both of those to really work with fractions pretty well.